and we are going to be solving Dirtybird 2. First of all, it's calling Dirtybird 2 because I reuse a challenge created by Ignacio. Let's start it. But I just add a new vulnerability, an unexpected vulnerability. So in order to not just repeat all the vulnerabilities, I just reuse the code at this vulnerability and maintain the name. So thank you for Ignacio for creating this awesome initial web challenge because it had a lot of code. It was very beautiful. I don't create beautiful web challenges, so it was a pleasure to just use his template.
Yeah, I believe this challenge was first done in Grimcon 2020. It got 0 solves,
Wow.
so I made it a bit easier, and then it was again used in Nahamcon 2021, and ever since it's just been sitting in our challenge library, never used again. So I'm super grateful that you were able to make it into something cool.
So let's see now first. Let's get started with this. You get a Twitter-like prompt to sign it. So we are just going to create a user. We sign up. We log in. Now that we are inside, we start checking that we have some interesting functionalities. We can see here some nice people to follow, like Ignacio, like John. You cannot see me, so you cannot follow me from here. It is what it
Yeah,
is.
I totally forgot to update it
Come on,
before
man.
pushing it.
And another thing you can do that is pretty interesting is that you can publish a tweet. So let's do that. Hey Ignacio, are you following me? And if we capture the tweet, we get a post tweet with some content in JSON format, pretty interesting. And it will be just, it is tweet or is not tweet? I don't remember this. I cannot see my tweet. But yeah, we are just sending a tweet with some content. Let's also take a look to what you can check here, okay? You can find this. Hashtag mustache life. Hashtag security. Awesome. So you actually don't have that many ways to interact with the web page. It's kind of cool because there are a lot of nice views, but you only can create an account, you can log in, you can sign out, and you can send a tweet, or you can search. Can you search like this? Oh, you can search. If I search.
I don't remember, to be fair. I think you can also change your profile pic.
You can change your profile pic.
Yeah.
View profile. Yeah, in edit profile
Trying
probably.
to create some functionality to confuse people.
You can, oh yeah. It looks like you can change this thing. Oh man, this is awful, man. People will get super confused with this. Cool. Well, we can change. We won't be needing this for solving the CTF. So if you do some brute force, we'll find package.json, and you will see something interesting. Actually, for dependency confusion, just going back to Ignacio's challenge, if you find a package JSON inside an application, this is awesome because you could be able to find the name of internal dependencies and trying to abuse that dependency with a dependency confusion vulnerability. Ignacio has already spoken about this, so we won't need to exploit this in this challenge, but we can see that we have lodas for 17.4. If we search this in Google, where is my Brave? Yeah. Lodas prototype pollution. Oh man. We can see that versions prior to 4.17.19 are vulnerable to prototype pollution. This is actually vulnerable. This has a minor version, so it is vulnerable. So if we send here a prototype pollution exploit, we will be able to pollute something. The question will be, what can we pollute? So you needed to find this this special, actually let's get this first, this special endpoint called health that I need to change the endpoint. Okay, let me change this endpoint. Actually, that's the same one. So if we attack what we are supposed to be attacking, we are going to get this success false message not admin. Well, this is where things get really complicated because this is a black box. Initially, we thought about putting this as a white box, publishing the code, but just to give some extra complication to the challenge, we decided not to because people at the end had access to this package JSON file. So you needed to brute force and find this health endpoint that will tell you, hey, you are not an admin, but you know you have this prototype pollution vulnerability, so you should be doing something about this. So what you are going to be doing is sending a tweet exploiting the prototype pollution. Hey, how can you know this is vulnerable to prototype pollution? Well, you know that there is a library being vulnerable. You are sending a JSON content here, so this and you don't have a lot of other functionality, so it's high probable that this is the place that is vulnerable. So we are going to be polluting the isadmin through I guess you could have tried with things like isadmin or admin. Well, at some point you will have discovered that isadmin is the endpoint, the attribute you need to pollute. So if we
Yeah,
send,
that's actually, you can see that in the JWT token. So if you go ahead and decode that cookie that you're
okay,
sending,
yeah, I
there is
totally
an
forgot.
isadmin equals to 0.
I totally forgot that part. Glad I have you here. Come on. Oh, you have isadmin. Yeah, awesome. So you didn't need to guess this part. That's great. I also remember that you needed to guess it, but I thought it was because we were giving the code. Okay, so the way will be that you just decode this cookie, find this isadmin attribute, you pollute it as true. Did I change? No. So let's move this to the repeater. Let's get this pollution. Application JSON, this would be tweet. Success true. If now we try to go to health again, we will get false, host is down. There is something going on here. Let me drop this and start another one because I think I might have polluted initially without wanting that. I don't know. If I generate a new instance, will it create a new instance, or because I have just stopped it, it will be giving me the same one?
As soon as you click stop or restart, it schedules it for being killed by Terraform, by Kubernetes. So that pod is gone forever.
Okay.
So when you click start, it's a brand new deployment with a brand new pod.
Awesome. So let's deploy a new one and start that again. Okay. I'm also going to do something, and it's that I'm going to remove, if I find it here, I'm going to remove all the cookies. Clear. Cool. Okay. Do I have intercept? Okay. This is working. So let's do again. Sign up. Login. We get this. Let me create a tweet. We grab this. Send to repeater. Actually, I don't know if I can do bigger the repeater. I don't think so. No. Well, I hope people can read what I'm showing here. Um, so now we want to check if we can access the health false not an admin. So if we now send this to tweet, submit true, success true. Yeah, we get from the previous response not an admin to the new response host is down. Actually, I don't know if it worked previously and I didn't notice. Anyway, we have successfully prototype pollute that is admin parameter. So now we need to learn how can we use this health endpoint. So the way to use the health endpoint, and I'm going to can I show them the code, Ignacio? It's okay for you.
Yeah, totally fine.
Okay. So if I show the health endpoint, we can see that what we have here is it is expecting the check IP parameter and is then going to be running a ping over that IP address, expected IP address. So if I do health check IP like this, it will say me, hey, host is up. If I do something like it's going to be host is down, and if I do something like this, it is not going to be sleeping. This is because we are setting here the input of the user as a parameter. So you cannot break the cell here. All that you put here is going to be considered part of the attribute. And actually, if we send something like this, note that here we are setting a reverse cell inside this tilde, I don't know how you pronounce this characters. This should be able to send us a reverse cell to us. This will be setting, whoa. Okay, let me create a new one. I thought I had it. ngrok TCP 444. One simultaneous ngrok. So the ngrok session is somewhere in there. Awesome. Oh, okay, it's here. So if I try to catch a reverse cell using these characters, like, because you might be thinking, okay, like I need to send something in a parameter, so I'm going to try to execute something before the parameter is being used. If we send this, we are not going to catch anything, because the code, when you set a parameter this way between this array, it will tell, hey, this is a parameter. This is not something you need to execute. This is just a string. This is just a string. So it's going to be sanitizing these weird characters you can put to execute code. So how can we avoid this? If you take a look to the internal library of child process in Node, you will be able to find that there are ways to pollute stuff that will allow you to execute code. Actually, there are some hints in hack tricks. If we go to prototype pollution to RC, prototype pollution to RC, we can see that, for example, in the fork exploitation, you can override things like exec path, argv0, exec arg. So there are things that will allow you to execute code, even if you only have control for in a few parameters. In this case, what you could pollute was the where is it? Is the cell attribute. In a spawn function, if you set cell, which is going to be undefined, as true, what is going to happen underneath is that instead of spawn treating this as an array of arguments, this is going to be treating this as an array of strings to join them together in a cell and then execute them. So all the protections that we talked about previously aren't going to work. So actually, for this challenge, you needed to exploit the prototype pollution twice. Once to get to be an admin, and the other one to get RC from the prototype pollution. So we send this, cell is now true, success true. And if we try this, we don't have any response, which is a really nice thing to happen. We are going to have our cell here, and we are going to be able to cut the flag. So you needed to exploit prototype pollution twice in a black box manner. So kudos to all of you that found the check IP parameter to do this, and also kudos to all of you that found that, well, you could prototype the cell attribute in order to actually force an RC. I'm not really sure if there are other things you could pollute apart from cell to get RC in this case. But I thought that it was very interesting because there is a default exploit that all the people will use for when you have prototype pollution vulnerability to try to get a cell, and I make sure that you couldn't use that to get a cell in this exercise, in this CTF. So you really needed to know about these or other attributes that won't be easily found in a write-up. I will be giving a couple of seconds to the people watching this in case they have any questions. In the meantime, Ignacio, what are your thoughts about this challenge?
This challenge is crazy. Now that we've gone through it, I'm really impressed with the 4 teams that solved it. I think it was 4 of them. This challenge is really tough, especially being a black box. That was a bit of my fault, but because we thought that we were going to do white box, and then I decided that maybe it wasn't that necessary. Kind of dropped the conversation with Carlos about it, and ended up going black box. Halfway through the competition, I realized maybe we should have given the code, but at that point, it already had 2 solves, and it wouldn't be fair on them to give the code after that, since they had solved a way more complex challenge than the rest. I'm looking forward to seeing some of the write-ups. Hopefully, they're already online and I can take a look at them.
Yeah, man, I was very, 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 very surprised that people managed to solve this without the code. Just because what I have said, you needed to find this check IP parameter, which isn't that easy to find. So I don't know if any of the people that solved this challenge is seeing this or will see this in the future. Please send me your write-up or tell me how you find this parameter, because it's super curious that you managed to do it. Or maybe you found an unintended way, and that's also crazy. So just share that. Can you repeat how the cell attribute work in this case? Sure. So if you take a look to the internals of child process Node.js library, you will be finding that a lot of attributes are undefined. So we were just looking for an attribute that we could modify to give us a way to execute code. You will see several of them, but one very important one is the cell one. The cell one inside this library can decide 3 things. You can set it to indicate the cell you want to run, like BNSH. You can leave it as undefined, so Node is going to get for you the default cell. If you are in Linux, this is going to be, I don't know if it's going to be BNSH or BinBash. Or you can set it as a Boolean. If you set it as a Boolean, Node is going to be getting the default cell for you, BNSH in Linux, but that will indicate that the parameters you send to this function aren't raw parameters and are just stuff to be concatenated inside the CLI, inside the command line that is going to be run by BNSH. So if you set cell as true, instead of saying, hey, these are just parameters, sanitize them and use them as parameters, it's going to say, hey, just concatenate all this string and execute it in a regular cell. So this way you will be able to abuse the final cell line and execute arbitrary code. That was the beauty of this challenge. It was that you cannot use the regular way to get RC. You needed to find another attribute like cell to make it behave differently. This was because you usually in other CTF you will have access to other parameters. In this case, you will only have access to this initial parameter. Also, I'm not sure this is the only way to solve this challenge. I know you will need to use prototype pollution and use some kind of new magic that doesn't appear in regular write-ups. But I'm pretty sure that there will be other ways to do it. So, but this was the one I used to solve it. If anyone has any other question, feel free to send. If not, if you want Ignacio to share one last solution.
Yeah, that would be nice. Let me set up again. Cool. Share my screen. I think that should be sharing. Yeah, I can see it on Twitch.
Yeah. Victor, let me talk to you after. We can discuss about that later. Sorry, Ignacio.
Yeah, no problem. So we're going to solve chatter, which was rated as hard, 5 solves. That's pretty normal for a hard challenge in one of the CTFs. And it talks about a desktop app for chatting, and it gives you some advice on how to configure the app. But yeah, if you download this, you will end up with a Electron app.
Mm-hmm.
Let's see. Yeah, so I can run that app by doing a chatter app image. Actually, let me start the server, and while it starts, we can actually look into the code of the chat image. If you do chat image app image extract, you're able to extract the actual code. Let's see. Yeah, we can see here there's now a folder called squash fs root. That's a file system that app image uses to store the things.
Can
So if we,
you put the letter bigger?
yes, I can, and I can make this a bit wider. That should hopefully help. So changing into that directory. It's been a long time since I've done this, like since August. So bear with me a second while I figure it out. So yeah, this is the content of the app, and I'm pretty sure inside app. Oh, that's an executable. Resources. It might be resources. Yeah, this app asar thing. I have it on my bash history. Yeah, this. So looks like I'm in the wrong directory to do that. Cool.
Can you make the letter a little bit bigger, even more? Cool.
Let me make it this extra big. Cool. So hopefully this is now something that we can see. Again, looking for app.asr. Yeah. So this is the command we want. It's using an npm package called asr, and it's basically extracting how Electron packages the app.
Mm-hmm.
Hopefully that worked. And now we do have, where does it put it? Assets, I think, is new. It put it in that directory. What a fail. So it's all mixed up, but yeah, it is here. Maybe if I put it as a list, is more viewable. So we have our main.js, index.html, manifest, node modules, all that kind of thing that you would expect from a Electron app. And I'm pretty sure the interesting part would be main.js. Let's cut it out. So it's a pretty standard React app. The interesting things that we could see here is that this doesn't use a sandbox. Where do I see this?
I saw it at the beginning.
Am I blind?
Yeah, in web preferences.
Oh yeah, sandbox false here. So this sandbox thing means that when Electron runs their applications inside like Chrome, essentially, it's a version of Chromium. And when it does that, it's able to do like the JavaScript inside Node. The JavaScript inside the Electron application is not Node.js, it's just basic JavaScript that you can run in a browser. In this case, since we have Node integration to true and sandbox to false, it's possible to run Node.js commands from within the browser. So essentially, having an XSS in this Node application